All right, I'm gonna get started. Can somebody just text me and let me know whether or not you can hear me? All right. You're muted, so if you want to, so I'm gonna start you muted. So if you want to say something, you'll have to unmute yourself, or you can send a message in the chat window. And I'll try and check the chat stuff periodically. Just let me go and record this meeting. All right. So I should be recording the meeting now. There was a question from Aaron about 3.4 and 3.5. Is that right? So that was the first question that came in. All right, so I'm gonna do 3.4 and 3.5 really quickly, assuming that I can find it. Okay, so let me go share my screen. All right. Schema refinement 3.4. The only two tables you need to worry about are order details and products. So if you could take a look at these tables, we're going to look at order details first. I probably have to go and connect to the right schema. All right, so basically, that's the order details. So I've messed around with this quite a few times. So I'm going to go into my SQL Workbench and classic cars, and so order details. So this is classic cars in my database. I'm going to go create another table. So I'm just going to basically do create. So this is the default. You don't need to do this. I'm just resetting it to a default space because I've already made improvements in this. So I'm just going to say create table order details new as. So that should go and create. So if I refresh my schema, so that's the one I just created. All right, so let's take a look at this thing. Product code is clearly a foreign key into products. So I'm going to do the same thing. I'm going to go and basically say, I'm going to go and create products, copy as select star from class occurs products. Right, so now I'm just got these things reset. All right. I have a feeling that I messed that up somehow. All right, so let's go take a look at product copies. You can see that it's already set them to not null. It's pretty clear that that's a primary key. So the product code, it's pretty clear that that's a primary key. So the first change that I would make is just to actually just set that as a primary key. Now, if you want to make your changes in Workbench, and then just copy the final things over into Jupyter, as opposed to typing the weird commands, that's also fine. What I typically do, just for clarity, is I'll do them here, but then I'll also just copy them over into the notebook. And just to make sure that I don't accidentally run them, I just put them in here so I have a record of what I did. You don't need to do that unless you want to, but I'm going to go and create. All right, so that was change number 1. Would be an example. That's clearly the primary key. These are already all not null, and they've been converted into types, so decimal, small int, not in this weird text situation. So not null has been set, and these are types. They're just not the generic test. So let's go back and take a look at this again. So this is the data that's in that table. When I talk about probing a table, these are some things I do. So an example is, I'm going to do select distinct product scale. From classic cars products copy. That is clearly an enum. And so what I would do is I would go back in here and say, product scale, that is not just freeform text. That's an enum. And the values are like 110, 12. Let's go back over here, 110, 112, 1872. Where am I doing this thing? I lost track of where I am. So
HR.
It's an enum. It's 1:10.
HR.
Enum 1:10 quote 1:12 quote comma 1872. Yeah, so that's really not going to. I'm just going to write these things down because changing screens like that. So it's 10, 12, 18, 72, 24, 32, 50, 700. Go back here and do this now. That's going to be an enum quote 1:10, 1:12, 1:18, 1:72, 1:24. Oh, mother of God. Let's try it this way. Enum. Quote 1:10. Quote 1:12. Quote 1:18. Quote 1:24. 1:72. Quote 1:32. Quote comma. Quote 1:50. Quote comma. Quote 1:700. Quote. And we're going to go back and turn that into 50. So I'm going to apply that. And again, I'm just going to make a copy of it. So apply that. All right, so it worked. And so now this thing's an enum because clearly that is not free-form text. So let's go see whether we can infer anything else from this one. Product line. We're in question 3.4. Product line is clearly a foreign key relationship to product lines, but I told you to not worry about that table. So the only two tables you need to worry about are products and order details. This one we fixed. Product vendor, you can go back and do the same game that I did. Just select distinct product vendor. That's a lot of entries. Typically, you would never make this in enum. And moreover, this is just a bad design. You would never put a vendor name in there. Basically, you would have an ID for the vendor, and that'd be a separate vendor table. So we're not going to worry about that one. Not null is good enough for that. Product descriptions, query text. So what are some other things you could do here? These are clearly numbers, and they clearly have to be positive. So the other thing that I would do on this is I would just basically go in and say, and again, I'm going off of my copy because I've already done it, but I would go in and alter this table. Actually, I already have the alter table open. Right, so I would go in here and I would say, I'm going to make a trigger. It's going to be a before insert trigger. Let's make it a little bit bigger. And so basically what I would say is if new dot quantity in stock is less than 0, signal SQL state, quote, 501001, quote, set message text equal to negative inventory. Really? And DIF, right? You see the same thing. So the next one is buy price. less than 0. Give it the same message. Negative price, really? And then I guess it's MSRP. Yeah, MSRP. And so that trigger, go back and take a look at this. That's just free form text, so there's not much we can do about that. It's just not null. This is just a bad design. Right? This should, sorry, this is a foreign key. And so I told you not to worry, but in a real system, this would be a foreign key into product lines. That we made an enum. This is a bad design. You would never put the vendor name in there. You would have an ID that references the vendor. This is just text. These are already not null, so the only thing we can do, and the fact that they are numbers means you can't enter banana. So if you go back and take a look, these are set to decimal or integer. So you don't have to worry about people entering strings. So the only other thing you can do at this point is just protect the values. And the only rule that I can clearly come up with is that none of these numbers could be 0. You could argue that the buy price can't be 0 and the manufacturer's suggested retail price can't be 0, but we're not going to worry about that. And so all we're really going to do at this point is just apply that. And what did I do wrong here? Bad SQL state 5001. So we will just go cancel that. It's one digit too many is the problem. So we'll try this again. All right. So I told you only needed to worry about the insert triggers. You know, if I decided that I was going to try and insert something in here, that one, so this one. Usually there's a lightning bolt here for form. Oh. So anyway, if I just went back in here and said, look, I'm going to go and try and insert something that was negative. So I'm just basically going to go and say insert into products copy values one motorcycles quote 1:10 red start So if I try and run this, you can see that I get an error down here saying negative inventory, really? So if I go set that one to 10, go set this one to -3. So negative price, really? So when you go back here, the columns are not null. They're typed. So for instance, these are decimal numbers, which means you can't enter character strings. This is an int, which means you can't enter character string. This one's clearly got fixed values. So that's an enum. So all I would really do at this point for this submission is that if you didn't want to copy this stuff over, all you really need to do for that particular submission is, this is the other trick. You can just basically, I just either just copy to the clipboard, the create statement, and then just go back in here. And that's good enough. It'll just show us what changes you made. And then if you did a trigger, I would just go back and alter into the alter table, triggers. Then you can just copy the trigger definition. And that would be enough for 3.4 for products. If you go take a look at, all right, so probably, I'm assuming that we're taking family photos and screenshots. I'm going to pause a minute so you can take your family photograph. All right, so that's the family photograph for the trigger. And then if you want the family photograph for the columns, that's what it looks like for the columns. So you can just take a screen capture if you want. So we're just going to close all of this stuff. Yeah, I don't want to do that. So let's go take a look at order details new. So there's a couple of things that I would do here. Let's go take a look at the schema. All right, well, the first thing I would do is there's clearly a foreign key relationship. The reference table, in my case, since I made a copy, you don't need to make a copy. It's just I fixed this to do the answer. And so I'm just showing you the steps that I went through to get it. So it references product copy, and the product code references product code. All right, so now I've got the foreign key relationship. The primary key in this one is order number and order line number. The order number, obviously, there could be many instances of an order number. There's going to be one for each order line number. So you can just apply that. All right, so let's go back and take a look at the data. So we've handled this column. We've made sure that this combination is unique. We can play the same game we did previously. So we can just go in and say, well, we're going to alter this thing. And we'll do a trigger, and it'll be before insert trigger. Normally you would also do an update trigger, but I told you in the problem definition that you only really need to worry about crate triggers. And so you do the same thing that you did before. If new dot quantity order less than or equal to 0, then signal SQL state 0.002 set message text. Too nice try. DIF. And this language doesn't have colons. For those of you that are computer science majors, you'll spend the rest of your life trapped in limbo between the various languages you're using. Price each. I mean, so that basically could be what you would do. Now, somebody asked an interesting question. If you could take a look at this, you can see it goes 1, 2, 3, 4. How does somebody who's doing an insert know that the next one for order 1001 is 5? You know, what's going to stop them? The primary key is going to stop them from overwriting 1, but what's going to stop them from like setting it to 2713? I wouldn't expect you to do this, But you can also do this, which is declare line item count int. So I'm declaring a variable line item count. I'm going to say select count of star into li count, where order number is equal to new dot order number. So what this is going to say is new dot order number is the order number for the tuple that's being inserted. This is going to count how many are in there before you do this insert, and it's going to put that value in li count. Right, so select count of star into li count. Select count of star. Select count of star from order details new where. Yeah. So now it's going to have the count. I'm going to go say set li count is equal to li count. Sorry, set new order line number equal to li count 1. And so no matter what you give me, I'm going to set it to the next one. And so you could do that if you wanted to. So I'm going to go apply this. So let's go back here, go to order details new, and I'm just going to go insert into order details new values 10100 S24, it's going to be quoted S24 3969, quantities 10, price each is 10, and then I'm going to say this is 2,713. So that's the line order line number I'm trying to give it. When I insert it, it says fine. But when I go back in here, you can see that it's actually 5. It just ignored the fact that I suggested, 2713. So just ignore that and computed it. So we'll go back over here. I'll make that a little bit smaller. So you can take a family photo of that. So I'm just going to copy it. And so this one I'll go put down here. And let's go back and copy the create table statement. So you can see that most of this was fine. The only thing that I really did was add the foreign key constraint and then the trigger. And so that would be fine for a 3.5. All right. Oh, sorry, 3.4. 3.5, modeling inheritance in SQL. This one's, we kind of went through this in class a couple times. This is the schema. So I decided to do a 3-table solution. So this person, that's got the person properties, uni, last name, first name, email. The primary key is uni, and I decided to make email unique. There's create table student. It's got a uni, a major, and the advisor, which is the uni of the advisor. The uni is a primary key. I also have an index on advisor because I'm going to need that for the foreign key. And there's 2 foreign key constraints. The advisor in a student has to reference a uni in faculty. Otherwise, it's an error. And the uni in student has to reference a uni in person. And so that's what you need for student. And then create table faculty. I'm going to say, this is 3.5, right? Varchar 12 is a uni, title, it's a primary key, and it references it. So that's pretty much the schema. Let's see whether I can go find another window. I'm going to lucid chart. All right, so this is the schema diagram that I did. Basically, the way I did that is I went into SQL Workbench, and I basically said I'm going to reverse engineer. I'm going to continue. The database that I'm doing is W411 final. I don't want the views or anything, so I'm just going to go and say, okay, I'm in Sequila. I don't want Sequila, so we're going to go back. Don't need that. We'll continue. Don't need that. Show the filter. Deselect all of them. And so I'm basically going to say I want faculty, person, and student for this one. So I'm just going to execute that. And so it's going to give them to me. So then all I really did at that point was just basically capture it. And I went into that other tool that I was using. And then I just drew lines. All right, so what do you do if you don't have this tool? Basically just go into PowerPoint or Google Draw, whatever you use. And then you just go and draw a line. So you can just do it with this, but basically what this is saying is that this is the core of it. This is what you can actually get. Don't worry about the dotted lines and these endings. And then basically I would just go in and these are the inheritance, and then you would just go put that in there. So that's how I get the diagram for the problem. But I just did it in this one because I use this to edit my schema. So that is how I get the diagram. The code, let's go see whether I can go find the code. Some of you have had problems with this. And this is part of what happens when I try to write code on demand. during a recitation. So for reasons that are not clear to me, I don't think you need to copy that over again. So these are the first two. So this is the notebook that we're working on. So I'm just going to go, I don't need that PyMySQL JSON twice. So I'm just going to run this cell, and then I'm going to make a new one. All right. People asked on Piazza. So the question is, can you draw it and scan it in instead of using PPT? It's more work that way, but if you want, what you can do is you can just, if you don't even need to scan it in, as long as you draw it legibly, you can take a photograph of it and then use that instead. I'm not hung up on exactly how you do it. You can draw it on a whiteboard and photograph it. You can write it on the back of your hand and photograph it. I'm not hung up on exactly the mechanism that you use to do it, just as long as you draw it. So yeah, you don't have to use PowerPoint or any diagramming tool. You can use whatever you want. I don't care which order last name and first name are in the uni. What I actually do in the code, I think, is slightly different from the problem specification. But given a last name and a first name, this just takes the first two characters of each, makes a prefix. Now, I think there's some errors in the versions that I did in recitation. Specifically, they may not have that part. Those two parts there. The way that I wrote run Q, that function, is you'll notice that it'll take a cursor. If it doesn't get a cursor, it makes a cursor in a connection, runs it, and then if you say commit, if you do not specify commit, it won't commit it. Students have hit two problems. The first one is that if you think about it, if you don't pass the cursor in, it's going to make one and run Q, but it's not going to commit. And so the update is going to be committed, so you might not see it in MySQL Workbench. And because you didn't pass the cursor in, it started a separate transaction. And so that write occurred under a separate transaction, which means that the next one is running in a different transaction and it can't see that insert, so it won't see the person. So if you're getting deadlocks or things are not showing up, it's probably because I was just sleepy during a recitation and just forgot to put this in. But that's how they should end, is in essence you're saying this function should not commit, but it should run as part of the transaction that called it. And so you may have those problems. So I'm going to go run this. And then I'll go create a faculty. All right, so Dark Lord is already there. So we're now going to go, it is Wizard Sauerman. And he is ws@orthanc.org. All right, so it made it. And that uni is going to be, it's going to be WISA2, right? Retrieve person, yeah, because I didn't write the function. So I'll go back over here. So that's create faculty. I'll go do retrieve person. Go add that. run it. And so you can see that it's got Sauermann. So when I'm done, I'll go back and just show you all of them. So I'll take the photos one at a time. This is create student. So if you look at it, it's basically the same. You just need to make sure that you pass these things in. The basic logic is connect, get a cursor, set the transaction level to isolate serializable, compute the uni prefix, go count how many things have that prefix, increment it, that's the new uni, insert the uni into person, insert the student data into student, and then commit. These two things run under the transaction you created here, so they'll either both happen or not. And the isolation level helps prevent two different things from sort of reading the table and computing different unis. The primary keys also help. So I'll create a student. So I'm going to basically go back in here, and it's going to be GMG Sam at shire.gov. He studied government. And then we're just going to go, and that's going to be GASA1. And I got to go do retrieve student.
And then there will be ordinance. Because inevitably it takes me forever to do the lights. And the lights are a one-person job.
And so there's Sam Gamgee. So I'm just going to go back and let you take photographs of them one at a time as I walk through it. So that one we covered, compute the uni prefix. Just going to take the last name and the first name, get the 2 digits. Grade faculty, last name, first name, email, title. Connect to the database. Normally, you wouldn't do it this way. Environments typically have something called a connection pool. I went over it once in class. It's not urgent. If you have lots of connections to a database, the database starts to act a little weird. And so environments that run transactions will pre-allocate a set of connections and just cycle through them. Because if you've got hundreds of running transactions, you don't want hundreds of connections. You'll say the maximum number of connections I can have is 10 or 15. And so the transaction will try and get a connection. If it can't get one, it waits until one is free. So I explained the concept in class, but it's kind of a subtle thing, so don't worry about it. I'm going to connect. I'm going to create a cursor. I'm going to set the isolation level to the strictest level. Compute the uni prefix. Count how many things in people have that uni prefix. Just going to run that. I'm running it under the transaction. So now, to some extent, I've actually kind of done a read lock. I'm going to get the value for the next one. I'm going to insert the uni value, last name, first name, email into person. And I'm going to use the transaction so that it either happens or not. Then I'm going to insert the faculty stuff and then commit. So that's compute uni and create faculty. Create student. So I just pause there. I'm assuming you've had a chance to take a picture, but let's just not. All right, so we'll go to this one. That's create student. Same basic logic. And then this is retrieve person and retrieve student. Retrieve person and retrieve student. All right, so that's 3, 5, and 3, 6. Sorry, 3, 4, and 3, 5. And then I have time to go over one more. So I'll go over 3.8 because there was a request for that. Yeah, this one's kind of tricky. This is all the setup. It's all the setup. So explanation, answer. This creates an account. So what I basically do is same thing. Get a connection, get a cursor, set the transaction level to serializable. I generate a UUID. So it's going to be just a randomly unique number. And I insert into banking account the balance and the version number. If you look, the ID is auto increment. So I don't need to set that. It's going to get added. And so what I do is I insert into banking account balance and version. Those are the values. I run the query, passing the values, fetches true, commits false, cursor. So now that insert is going to occur within a transaction. Since I haven't committed, if I go say select the maximum ID as the new ID from banking, the one I just submitted will be the largest, inserted will be the largest value because of the transaction. If somebody else inserts one, I can't see it. So the largest one, because the largest one, because it's auto increment, will be the one I just inserted. And so that's how I know what the new ID is. So I just run that, and I'll go create an account. Right, and create account balance, and I'm just going to go run it. So I created an account, 999. So this is going to get a balance. I'll just save that so you can take a picture of it. That just creates an account. This gets the balance. Right. This thing here that I keep doing over and over again is really poor coding. In general, you don't want to have the same snippet of code repeated over and over again, but I decided not to put it in a separate function because you then have to, as you're trying to understand this, kind of go into the other function, figure out what's going on, and come back. So I just keep putting it here, but don't consider this to be good style. So if I've got a cursor, there's no cursor, get a connection, blah, 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 blah. I'm going to do the select to get the account, right? Result. So select, blah, blah, blah. Result is Q. Commit, and then I just get the balance property. So if I go in here and say, get the balance of account 9. Oh, got to run it. The balance is 999, which is the one that I just created. So just pause here so you can take a look at that. So this is just getting the balance. Now, if I go in, I'm going to go write a function get account. So I'm going to add a cell here.
Yep, that's it.
So go back over here.
I think so.
So let's get balance. This is going to get the account. This does basically the same thing, only instead of returning the balance, it's going to return the entire account tuple. So select everything and then return the whole thing. So if I do get a count of 9, you can see that it gives me the entire account, the balance, the ID, and then some, the UUID. So just pause for a minute. That's get account. It's basically the same as get balance. So now I can get them. I have to be able to write them. So this is update balance. This stuff's all the same. Make a UUID, because if you go back to the description, I'm going the wrong way apparently. Why is my mouse going the wrong way? I'm like completely lost. All right, so you can see this statement's very important. Every time a program updates an account, it generates a new UUID. It's just in the specification. And so I'm always going to get the UUID. So this is just going to update the balance, because I'm going to compute a new UUID. You gave me the account number and the balance. I'm just going to go do that and update it. So you're just going to run that.
More.
So we'll just add this. It's account 9, and the balance is going to be 666. And then we'll go print get balance of 9 and just run that. So you can see previously, if you go back up here, balances were 999. Now it's 666. So that's update balance. This is update balance optimistic. So this is all the same. If you'll notice here, I do not read the data before I write it. I just do the update. You'll sometimes hear this referred to as a blind write, because you just kind of wrote it. Now the assumption is I read it some other way, but here it's just a blind write. This one's slightly different. It's saying, go get the account, so go read the whole record. So get account returns the whole record, including the version number. I'm giving you the version of the record that I read previously and the amount that I want you to set it to. So go get the current record. If the current version isn't the same, the version number has changed, it means that some other transaction has updated the account balance since I read it. So that's why the version numbers are there. And I just basically say failed. Otherwise, I'm going to make a UUID and then write it. So all I'm doing is I'm detecting, has this thing changed since I read it? So we'll just go around that one. And we'll just go see here, and we will go and insert a cell. Right. And so we're just going to say update. So basically we'll do the following thing, which is account is equal to get account of 9, print account. Right? And we will run that. So it's 9, the balance is 666, that's the version. So now what I'm just going to do is I'm going to go and insert a cell. Oops. View. I'm going to go and I'm going to get rid of that one and insert one here. I'm going to say update balance 9, and I'm going to make the balance 555 and run it. And it's going to work. And then what I'm going to do is I'm basically going to say update balance optimistic. I'm going to give you the account and I'm going to say I want the balance to be 1,000. And I'm going to run that. You can see the optimistic transaction failed because I read it and I've got the account on the version and I'm trying to update it, but it's changed since I read it. And so that is an optimistic transaction failure. This is just making it explicit by using version numbers. A transaction engine that does optimistic transactions does this automatically. You don't need to track version numbers. It knows which things have been read and changed, and it just handles it automatically. I just did it this way because almost no databases do optimistic transactions. It's just kind of a theoretical concept. And secondly, this is almost exactly the way e-tags work. You can think about an e-tag as being a generated version number. And so this is how e-tag processing would work on an update. So anyway, that's just an example of the conflict. This is the pessimistic transfer. So you can just take a screenshot of that. So that's transfer pessimistic. I'm going to get a connection and a cursor. I'm going to set isolation level. And basically, what's the source account? Get the balance, right? Do you want to continue? They want to continue. What's the target account? Get the balance. Do you want to continue? But you'll notice all of these calls are running on that cursor, which means that when I touch the record, I read lock it. So now when I get here, the source account and the target account are both read locked in this transaction. I ask you the amount. I compute the new balances. I write the new balances and then I commit. So that's pessimistic because I'm using locking. So what I'm going to do at this point, and I kind of messed up a little bit. I forgot that you don't all do your exams and homeworks the way that I do. So you don't have to do this if you don't want to. But basically, I'm going to go CD, Twiddle, Dropbox, Columbia courses, fall, W, and that's not particularly legible, but I'll make it a little bit bigger. So I'm going to go, and I've got a program here, test transactions. So I'm basically just going to copy this and go to both directories. All right, so I'm going to do Python test transactions. And it says, do you want to do it optimistically or pessimistically? All right, so I'm going to do both of them pessimistically. So the source account is 8. Yep, I want to continue. Target account is 9. Yep, I want to continue. So at this point, this transaction has read locked accounts 8 and 9. I'm going to do this one pessimistically. I'm going to say the source account is 9. I want to continue. Target account is 8. I want to continue. Now you'll notice when I type 50 here, that hangs. It just seems to stop. And the reason is that this transaction is trying to update accounts 8 and 9, but it can't do that because that requires a write lock. And this transaction has a read lock. And so you can't get a write lock. So this one's waiting for the read locks to be released. If I go down here and I type 50, this one, so this transaction's waiting on that one. This one, when it tries to write them, it's going to request a write lock, which means it's going to wait on that one. It's got the read lock, and that's going to cause a deadlock. So when I hit this, you'll see that one completes, and this one aborts because there's a deadlock. So what happened is when I tried to do the update, this transaction requested a write lock. It caused it to wait on this one. So that one was waiting on this one. This one was waiting on that one. The database engine detected that there was a graph, there was a cycle in the wait for graph. It aborted this one. When that one aborted, it released the read locks, which means this one could get its write locks and it completed. So that's pessimistic. What happens when you do it pessimistically? So we'll just try it again. And in this case, we'll go, but we want to do it optimistically. So the source is 8. I want to continue. The target's 9. I want to continue. The amount's 100. I'm not going to enter it yet. And now I'm going to do this pessimistically. This one I'm going to do pessimistically. So I'm going to go, it's pessimistic. Source is 8. Yes. Target's 9. Yes. Now you'll notice this is where they hung last time. But if I type 50 here, that one just goes fine. Because this transaction's optimistic, it does not keep a lock on the data. It's going to detect a conflict at commit. So if I try and go 33 here, it says got an exception, optimistic transaction failure. And so this one didn't hold locks, it just read them and it's trying to detect a conflict. So despite the fact that it read them, it's not holding locks and this one could go through. So that's kind of, the definition of optimistic. There was a request to go over star schema. Unfortunately, I don't have enough time to go over it right now. I did go over it extensively. So Allison Costa posted. I went through it really step by step in the recitation yesterday. So you can try following it there. I've got things to do in the morning and the early afternoon, but I'm going to get onto campus sometime, I don't know, around 4 or 5 o'clock. I'm not sure I'm going to schedule recitation, but I will be hanging out either in my office or in the computer science building. If people have problems, they can just come and see me. It might be kind of crowded, but I'll stay around for a few hours just to help people who are kind of trying to finalize their homeworks. Sorry, finalize their exams. So I'll be around. Um, I've got a couple of project reviews for my other class, but I'll just be on campus, I guess, from about 4 until 9 or 10 o'clock in case people need help. So um, this one's also being recorded. You can take a look at the one that got posted. And if anyone's confused, I can just go over it again and walk you through it. But I went through it really, really carefully, step by step, when I did it yesterday. So that video is pretty much just a recording of what I would have said. All right. So listen, you're all doing extremely well. I appreciate all the hard work that you're putting in. I know that class has been a lot of work, and your grades. I mean, because of the amount of work that you put in, I tend to be very, very. I wouldn't say lenient, but the average grade in my classes tends to be extremely high because of the amount of work that the students go through. So please do not be nervous about your grades in this class. I told you on the first lecture that there's a way for everyone to get an A, and it's my job to get everyone there. So I'll be around tomorrow. I'll be checking Piazza probably in the morning, but I'll be on campus in the afternoon. So I will talk to all of you later. Bye.